once upon a time, there was a developer who wanted to make a location-based time tracker application. And this application was meant to be very simple. It just wanted to log the departure and arrival time of this developer in a specific target location, like office. And important for this application was to using several input signals for deciding whether the device was in the location or not. Namely, the presence of a Wi-Fi network, a specific Wi-Fi network, and the GMS location. But for my story, it's important to know that this simple application in the end wasn't so simple, and the developer got frustrated using the GMS location manager and got very frustrated using the Wi-Fi manager, and in the end gave up building this application and started to use paper and pen to write down the arrival time of work. So I know this thing because I am this developer, and once upon a time, it's 3 years ago, when I first got my first Android device. So just short about myself. I'm a software developer at Satenbau and obviously Android developer. Actually, since 2 months at work, I got 2 Android projects. One of these is in collaboration with the University of Applied Science of Constance. There I'm helping 2 students with a bachelor arbeit thesis, which is about indoor positioning and indoor location. And this project kind of got me back into this all location stuff. I decided to give this talk, and I look into GitHub for finding my old code for 3 years ago. It's very ugly, and anyway, I made it run, and I look at the result, and I was thinking, like, why these failures? Like, I look at the better the result, and I kind of cluster the errors. Like, for instance, I have this problem of checking out from one location and checking in again very fast afterwards. This I call it like losing my Wi-Fi, because probably in one Wi-Fi scanning I wasn't finding a network. I was saying, okay, this means I check out from this place, and then in the next scan I was finding the network again, and I said, ooh, I'm in again. So I really had ugly data, and sometime I was thinking, okay, maybe I'm just going nuts. And in this example, like, I'm at Satenbau, but I check out afterwards from my place, from home, and then at the same time I'm checking in again at work. So somehow I didn't manage. I was frustrated. I had a lot of bugs because it was hard to combine the signals. It was very hard to work with Wi-Fi somehow. Yeah, anyway. What I wanted to do is to have to talk about what happens in the last 3 years in the field of the location, and to see if there are possibilities to solve this problem with easy location-based time logger in better ways. And I want to do that talking about which are the new things, like what happens in the location field. And one thing that maybe everybody notices is that location is growing of importance. All the main applications in the Play Store are using some location, like WhatsApp has a very nice feature, share my location, and the contacts can navigate to you. But really, a lot of the most popular applications are using location somehow. And then there are this kind of new application, which some people call contextual applications, like for instance Google Now, which is this, it works like this. There are some cards which pop up in your Android phone every time Google Now thinks you may need the most. And I look at the cards, there are maybe 40 different kind of cards, and a lot of them are really depending on location, either directly, like traffic or activity summary or location reminders, or some cards are kind of depending on location more indirectly. Like for instance, the translate cards pops up just if you are in a different country than the one you're spending most of the time. Or restaurant recommendations for the restaurants around you, or like offers for physical stores which are close where you are walking in or driving in, and so on. And why am I telling this? Because contextual applications have very different requirements on location than task-based applications like Google Maps. Google Maps wants always to know your most accurate location very frequently. And for instance, the weather part of Google now just want to know in which city you are. Okay, what else changed in the last years? Like always, in our field, there has been advancement in technology, better hardware, faster, and also developers and scientists got a bit more clever in using this hardware. For instance, in the last time, sensors become much more popular for doing location stuff. Like, sensors are not just anymore for playing games, but also for doing location stuff. And then there are indoor maps, which is a very interesting field. Google and other industry player really wants to get indoor and to offer geographic service also, not just when you're outdoor, but also when you're indoor. So this is what changed, and in May at the Google I/O, Google released some new APIs for Android and location and updates on all the APIs with the following goals. They wanted to improve the quality of the location. They wanted to simplify the APIs. Also, they wanted to somehow do some job in order to be able to have a better indoor location when in the next releases. They wanted to give us developers some new features. Well, and of course they wanted to make it available on the most Android devices that you could. So, I would like to go for each of these goals. I would like to say what happened in these releases. And the first was improving the quality of the location. And in order to do so, one should agree on what is quality for location, and use this model, the power accuracy coverage, which is a very simple but effective model to say what is quality. And one can go, for example, and explain it. For instance, for GPS, a location component, it's really bad with power, is good with accuracy, like 10 to 15 meters. And the coverage is okay, like outdoor is good, but inside a building you don't get any GPS signal, or almost nothing. Wi-Fi, which is not made for the location, could be used, and it scores okay in all these three factors, like okay power, okay coverage, like Wi-Fi is mostly indoor and you don't have outdoor, usually, well, not in the forest, let's say. And the accuracy is also okay, like you cannot really rely just on Wi-Fi to have an accurate position. Then there are GMS, which is very good with power, and I mean our phones need the signal anyway. It's very good with coverage, we have it indoor and outdoor, but it's bad with accuracy, that we cannot rely on this for getting a good location. And as I say before, there are these new things like sensors, which are more and more used to make optimization and improving the quality of the location. For instance, in order to save power, one could think about asking to not keeping on asking all the components for a new location when it's not needed. For instance, if you are staying in the same place, if you are sitting on your desk or if you are sleeping, you don't need to keep on adding a new location. You don't need to ask your GPS sensor for a new location. You could save your old location and keep on retrieving this one. And there is a sensor, which is the accelerometer, which tells you if you moved or if you didn't move. So if the accelerometer says, okay, I didn't move, then you don't need to ask for a new location. Then there are ways to improve the quality of the location, like the compass could retrieve the magnetic field of a certain position, and it's very interesting. There are some companies who are doing indoor positioning with using magnetic field, or like inside a building, the magnetic field is actually disturbed, and in this disturbance, one can retrieve some information. At least one can have a fingerprinting of this magnetic field's disturbances in a building. You could save it, and you can reuse it in order to do positioning indoor. And this is a way you can use compass for improve the accuracy of an indoor position. And also the barometer is a good quality sensor who can tell you if you're going up or down very easily. It's hard to use it for having absolute values, like now I'm up 400 meters on the sea level, because you have to recalibrate it every day, but it's very good in telling you if you're moving 1 meter up or down, once you know where you are.
Just a question about the use of the compass, the magnetic field measurement. Yes. Is that something that's actually demonstrated, or is it just an idea, or has anybody demonstrated?
There are a few companies really doing it and offering as APIs. There is a Finnish-based company, well, no, it's probably an American-based company, but they started in Finnish, some kind of university, Indoor Atlas, doing it and really try to get into the market. And there is an Italian company, GPS Tech, doing it. I'm aware of this too, but also as a research, it's also very, like, there are a lot of papers. But 2 companies are doing it like already professionally. So, and sensors also deserve their column in this table. So they're okay with power, they could help improving the accuracy, and it works everywhere. So, speaking of sensors, we can talk about how difficult it was with the old location APIs to combine different signals and doing this kind of optimization I was telling you about. This is also more or less the reason I gave up building my application. Whenever you have an API, like whenever you have to talk to several components, your application becomes much more difficult to use. And that was the case with the old APIs. They release a new API, which is called the Fuse Location API, which is a layer. It gets distributed with the Google Play services and talks to all these components, so also including the sensors for you, and it really offers you a very elegant and current API. It requires an input. If you ask for location, it requires an input the requirements of your application on the location manager in terms of priorities. Like a priority is what your application wants to have from the location. And there is the standard Google Maps, let's say, priority, which is high accuracy, which means always the better location signals and very frequent. There is balance power or low power priorities, but there is also a very funny, very interesting priority, which is no power. This is made for application that they could need the location, but location is optional for this application, and it doesn't require any power, and it works like this. If other applications are requiring a new location, this could be shared to applications who use this no power mode. So just if location is nice to have for your applications, then you can use no power.
Do you know if that requires the other apps to use Maps v2 too?
I believe not, because they just.
So I don't know.
Probably it requires the other app to use the Fuse location API.
Yeah.
Not necessarily Maps v2.
Yeah.
But yes, I believe so.
Okay. Yeah. So if you use Google Maps and has the GPS location, it probably doesn't help your app with no power.
I believe maybe. Google Maps in the new version is going to use the Fuse location.
Are you sure?
No. But I think there are some ideas.
There is in the old API there's this get passive location, so maybe it's using this one.
Okay. So this is a screenshot, like how to use this API. Which I think is a very nice API. You have a client, you have to call connect to this client. After the unconnected callback, you can ask for the old location and you can make a location request. And you tell here the priority you want to have. And then there is a location listener, which is called every time a location change. Another good thing is this API is that it's extendable. Like, I don't know if it's officially, but I think Google kind of tell you if there will be a new location component in the future available to a lot of devices, we will add a column and we will use it for giving you the best location possible according to your requirements. So for instance, a candidate for this extension could be the low energy Bluetooth that maybe will be out in the future, and whenever some application will ask for a low power location, you could use maybe cell and Bluetooth. I don't know, this is just speculation, but it's extendable. Okay, I don't have time to talk about indoor ones, so we'll see. And I will tell you about some new good features for us as a developer. One is geofencing, which means deciding a point, a geographic point, and a radius, and your application will be triggered every time the user enter or exit from this point. And this works very nicely if the application is running in foreground, or also if your application is running in the background. The API is also very nice and coherent with the Fuse location API. It shares the same client, the location client. On connect, you can create some geofences and add it to the client. And then you need a geofence intent receiver. We check just which kind of intent I received. If it's a geofence intent, you can find out if the user enter or exit and the ID of the geofence, and you can handle your geofence.
It's weird, actually, right? It's weird that you don't get the one geofence that it has been crossed. It would be nice to get the.
You get it in the intent. Yeah. You get the transition, and then.
But you have to go through.
Get trigger. You have to go. You have to call the location client and get trigger geofences. Oh. Because it doesn't have to be just one. It could be at the same time. You could have several geofences.
Intersecting.
Yes.
Or leaving one entering.
Yeah, exactly. And I have done for you. This is where I work. Exciting. And here on the back you see this tower, last tower. And I have an application which show you a map with 2 geofences. So I hope I can make it work. So yeah, this is my tablets. These are the 2 geofences, and I have just to fake my GPS signal, already prepare it. So I'm going close by, I'm passing by the office and I go to direction tower. So you can see, you can see that because I'm seeing it in my tongue. Just wear it. Okay, just a second.
Refresh. Right? It's not a video feed.
Yeah, I'm experimenting with. Just one second.
The refresh error in the second.
No, it's not refresh. It's
Okay.
But let me just restart this client. It's the first time I'm using it. So I think I'm running out of time.
Oh, you still have 8 minutes.
That's good. No screenshot. Is it considered like demos? So you see. Let me just clean them up. No. Okay, now it's my normal cache. Where are
It's upside down, you have to rotate.
Twisted seat.
yeah, it's, you see it just 2 minutes after, not 2 minutes, like 10 seconds after me. So, 1 second, let me do that, sure. Because okay. Just 1 second. Yeah. So you see the first geolocation, geofence has been triggered, and in the callback I will highlight the circle. Then, if you are lucky, the GPS will go in the intersections between the two geofences, and both geofences will be triggered. We're not so lucky. Somehow we didn't get it, but we got the second one. Well, that's with geofences. Alright. Another cool new feature is activity recognition, which just using sensor data, so no GPS, no other kind of location, is detecting the user physical activity. And this works using machine learning categorization. For instance, in this graphics you see, I think the data from the accelerometer sensor, if the user is walking or if the user is on a car. Which is very different and which make it a good problem for categorization. The API, once again, is very coherent with the old API. This time there is another kind of client, activity recognition client, which on Connect could request activity updates. And then there is intent service, which handles the intent and gets from the intent the activity recognition result, which are basically in vehicle, on bicycle, on foot, still utility.
Drunk, right?
Sorry?
When you're drunk enough?
No, utility means the system is kind of recognizing that you are changing activity. So maybe you were by bike and now you are going by foot, and this transition is classified as tilting. And there would be a choice between video time or live demo time. And for a live demo, I need a volunteer. Is there any volunteer that is going to walk around the building with my mobile? Or maybe we can do like this. I can show you a video and during...
I'll volunteer.
You volunteer, that's great. Maybe I can show you anyway a video. And during the... Maybe it's good during the Q&A. Okay. I show you the two parts video. This is activity recognition while being on the car, as you see. It's very fast. I click on start activity recognition. I'm on the Tesser bridge now, and very fast it recognizes that I'm on the car. And okay, this video is good. I want to pay attention because it was very dangerous for me for taking this video. And I'm on a bike. I'm filming myself with a tablet. So. So I'm sorry about the quality, but but you will see. Okay, now the first is a non-activity. Now it's tilting. It's slow, but now you can see.
Now you cry.
Now I'm on a bike. You recognize that I'm biking.
I'm on a bike. 10 seconds later.
Okay. And after this it is, the walking demo is very boring, so you can see it. I don't know if you want to have the slide. Okay, let me finish, then we can do the live demo. My key takeaways. So, Google focus for the question is improving the quality and the simplicity of the APIs. And the new APIs are Fusel caching provider, geofencing, and activity recognition. I believe contextual apps and applications which will work indoor will grow in importance. And also, even I can build location-based apps because I rebuild time trochoid with the same old ugly graphic, but using geofences instead of my custom algorithm. And I try it for 3 days. I get very consistent data, and I look at the data and I say, wow, this is fantastic. So maybe we can have the live demo and at the same time some questions. Let me just start the demo. Thanks for volunteering. So I have this application. We send data to this online spreadsheet, and you can go take my mobile, maybe you can put it on your phone. Have a walk, have a ride on a bike. Okay, I don't know if you have time for going by bike, but I will leave the screen on.
I'll just do my best.
Thank you.
You will never see yourself on a game.
You work with me.
But at least you have this position.
Yeah, that's true. Yeah, do you have any questions?
Do you need a data connection for this activity recognition? So is like the recognition done in the device or on some Google service?
Everything is made inside the device. So it would work offline. The only thing I need the network for is sending this result of the activity in this spreadsheet. Otherwise it works offline. Nicely. That's nice. We don't know.
I think they actually got the Wi-Fi location-based even more battery efficient, because in the last version, the 4.3 version of Android, you can now put it in passive mode, so it will only listen to the radio signals. It will never answer.
Sorry,
yeah. So it will only listen passively on the signals and get the SSIDs of of different stations, but it will never answer back, so you get very battery efficient solution even for Wi-Fi.
Okay.
So hopefully that one is being used more than it was before.
Okay, that's also good. I just 3 years ago really didn't like the Wi-Fi manager. I don't know.
So that probably you can see that in a lot of time trackers that they are complaining about they are logged out or logged in several times a day just because they are looking at the SSID instead of doing the position based, which is actually represented.
Yeah, exactly. And also Wi-Fi signal is not really stable. It could happen that sometimes just your device don't read it. So you have to, or if you want to do this application using Wi-Fi, you have to take maybe 5 minutes sample and to say, okay, do I still have the Wi-Fi or not? You cannot just trust one single scan.
Yeah. And in a bigger building, if you're in an office, you need to. I do need to check the network name, but that can of course be the same as some other place. Or you need to have the MAC address, and then you need to have all of them because you have more than one access point.
That's right.
So,
oh, maybe person is
You can't tell the difference between car and train. It's not
it's working.
You're surprised as we are.
I tried that to work like 1 week ago, and it didn't work that well. I guess my volunteer wasn't backing very good.
you should be able to see that as well.
That's what I'd like to see. It's just like on a train in Switzerland or
Yeah.
on a train in Russia.
Germany.
Bit different.
Maybe
On the train in Sweden would be the skill.
Yeah.
Maybe it's worth noting that there's a pretty good training session for the new kind of these APIs, and they also make good use of this activity recognition in their example, combining the efficiency mode with the activity you're doing. So if they recognize you're still, of course you don't need to pull any accurate, as you said already, accurate position, and if you're on foot, maybe you want to have GPS, but if you're in a car, maybe block range is okay. So combining those APIs is very useful, and it's pretty easy. You just need to copy the code from the training. So
one of these training sites is called Location Code Lab.
Lab?
Code Lab.
Code Lab.
Okay. Yeah. This is where I mean, in order to do my demos, I use a lot of this. Code.
And I heard that there's a limit on geofences, like
100
yeah.
per application. Like per application per user.
So you just create a lot of services with different names.
You have to do a super app that like intents go around this. Have you seen someone on the bike?
And someone going from
Or someone tilting? Have you seen someone tilting?
Probably that's stairs.
It can be also, I mean,
to tilting, when you walk up the stairs, the signal could be similar to when you go from walking to on a bicycle.
I mean, also walking inside a building is not the same as walking outside because you have doors, you have to open the doors, you have the stairs. So I think
You open the door very slowly, still.
it's this kind of thing. But you see, it does something.
So in general, it really works. Cool.
Yeah.
The geofence, can you use any arbitrary shape?
No, just the radius. But you can decide the size of the radius.
Maybe you can combine stuff with several geofence.
Right. You can use any shape that you made of
So you can make
radius.
of maximum 100.
That's right. Alright.
Very cool.
Thank you very much.